Okay, so finding the inverse of a trig function, so I have 2 sine x minus 1. So this gives me that my domain of my function is negative pi over 2 to pi over 2. And then to find my range, I can work with my midline and my amplitude. Since I have a midline of negative 1 and an amplitude of 2, I know that I'm going to have a maximum value of 1 and a minimum value of negative 3. So the range is going to be negative 3 to 1. So remember, the domain and range flip between the function and its inverse. So we know right off the bat that the domain of the inverse function is going to be negative 3 to 1. And the range of the inverse function is going to be negative pi over 2 to pi over 2. And now we just need to find the function itself. So we know we're going to change this to y, so y equals 2 sine x minus 1. I'm going to change x and y, so x equals 2 sine y minus 1. And now I'm just going to solve that new equation for y. So I'm going to add 1, so I get x plus 1 equals 2 sine y, and divide by 2. So I have x plus 1 over 2 is equal to sine y. And now we know to get rid of the sine, we need to do the inverse sine of both sides. So again, the inverse sine and sine cancel out, so that's going to leave me with y equals the inverse sine of x plus 1 over 2. And then we're just going to go ahead and change that to the inverse notation. So f inverse of x equals inverse sine of x plus 1 divided by 2. And so that is going to be my inverse function. Inverse sine of x plus 1 divided by 2. And there is all of the information that we need. So doing my next one, I got negative 2 cosine 3x. So I have the domain of f is given to me as 0 to pi over 3. And now I think of my range of f, so I have a midline of 0 and an amplitude of 2. So that's going to give me a minimum of negative 2 and a maximum of positive 2. So my range is going to be negative 2 to 2. So again, we know we're just going to flip those for my inverse. So the domain of my inverse function is going to be negative 2 to 2. And then the range of my inverse is going to be 0 to pi over 3. And now we just need to find the function itself. So I'm going to change the f inverse to y equals negative 2 cosine of 3x. Switch my x and y, so x equals negative 2 cosine 3y. I'm going to start by dividing by negative 2, so I get negative x over 2 is equal to cosine 3y. And since I now have that cosine term isolated, I need to take the inverse cosine of both sides. So I now have the inverse cosine of negative 1/2 x. If you want to write x over 2, that's fine. Is equal to 3y. And now to get y alone, I just need to divide by 3. So it gets me y equals the inverse cosine of negative 1/2 x divided by 3. And remember, dividing by 3 is the same as just multiplying by a third, so it looks a little nicer that way. So the inverse function is going to be 1/3 times the inverse cosine of negative 1/2 x. Inverse is equal to 1/3 times the inverse cosine of negative 1/2 x. And there is all of my information. Okay, so we did 4 of these problems last class. So remember, working with a composite, you start with the inside and then you're just going to work your way out. So I'm going to start, if I want to do inverse sine of the cosine of 5 pi over 3, I'm going to start by finding the cosine of 5 pi over 3, which I go to my unit circle. The cosine of 5 pi over 3 is 1/2. So I'm doing the inverse sine of 1/2. Remember, inverse sine is restricted to quadrants 1 and 4. So I have that y coordinate of 1/2 at pi over 6. So that is the value of that composite function, is pi over 6. Okay. Next one, inverse tangent of the sine of pi over 2. So I'm going to start by finding the sine of pi over 2, which is 1. So now I'm going to do the inverse tangent of 1. We know inverse tangents in quadrants 1 and 4. And I get a tangent of 1 at pi over 4. Because remember, pi over 4 gives me the coordinates radical 2 over 2, radical 2 over 2. So we know dividing anything by itself is 1. Next one, inverse tangent of the cosine of pi over 2. So the cosine of pi over 2 is 0. So I want the inverse tangent of 0. So where is y over x? 0, and that is going to be at 0 itself. Next one, the inverse cosine of the sine of pi over 6. The sine of pi over 6 is 1/2. So I'm going to do the inverse cosine of 1/2. So remember, inverse cosine is in quadrants 1 and 2. So I'm finding where my x coordinate is 1/2, and that is at pi over 3. Okay, next one. The tangent of inverse cosine of 1/2. So I'm going to start by doing the inverse cosine of 1/2. So where in quadrants 1 and 2 do I get x coordinate of 1/2? And that is at pi over 3. So I'm going to do the tangent at pi over 3. And remember, tangent is going to be y over x. So pi over 3, the coordinates are 1/2 radical 3 over 2. And so dividing y over x, radical 3 over 2 over 1/2, that gets me radical 3. Okay. Now, when you have a composite function with 3, it's the exact same thing. You're just going to be doing it all 3 times. So I'm going to start with the inverse sine of radical 3 over 2. So in quadrants 1 and 4, where do I get a y of radical 3 over 2? Is at pi over 3. So I now have the inverse sine of the cosine of pi over 3. And I now need to do this inner piece again. So the cosine of pi over 3. So I look, that is 1/2. So I'm now going to do the inverse sine of 1/2. And I have a y coordinate in quadrants 1 and 4 of 1/2 at pi over 6. So this whole composite is pi over 6. And my last one, so the tangent of inverse sine of the cosine of pi over 2. I'm going to start cosine of pi over 2 is 0. So I'm going to do the tangent of the inverse sine of 0. I'm not going to do that inside function again. So the inverse sine of 0 is 0. So now I'm evaluating the tangent of 0. Y over x, 0 divided by 1, gets me a value of 0.